Yes, welcome to our online class. Today we'll be discussing the root mean squared value of a transformer. And the problem here is that we should prove that the root mean squared value of the EMF induced in the winding of a transformer is given by E equals to 4.44 NAF B max in volts. So here your N is your number of turns, your A is the area, your F is the frequency, and your B is the maximum flux density. All your value is given what? In volts. So, solution. To start with, I'm going to draw the wave diagram of flux. So, our wave diagram of flux, wave diagram of flux, because that will enable us to determine the total flux. Now, I have this, so let's draw the wave cycle. So we have this and we have this. Now this is for the flux, and this side, this is my frequency. So this is a full circle. Now from here to here is 1 over f, is 1 over f. Now what all I need the maximum flux. So no, I told you from here to here is 1 over f. Now if I'm dealing with the maximum flux, this side will be what? Positive. Phi max, that's maximum. And here, this trough, this is the crest, this is trough, negative phi max also. But now I have to determine the average fluxes, here I have to determine the average rate of change of flux. Now before I do that, I know that from here to here, that is here, you give me what? That is half of this. So that is what? 1 over f divided by 2. That is 1 over 2f. Now, I will now determine the average rate of change of flux for this wave diagram. Now, my average rate of change of flux is given to be the positive minus this downside, the trough side. So it's also negative of this circle. So that will be minus this divided by what? The frequency. The frequency from here to here is half of this full frequency. So that is what? 1 over 2f. 1 over 2f. Now, that will give me what? This, let me just denote the max with m. Minus times minus will give me what? Plus. Divided by what? 1 over 2f. So, if I add this to this, that will give me what? Positive. 2 phi maximum divided by 1 over 2f. Now, by solving this, I will have 2 phi maximum multiplied by 2f. And that will give me what? 4 frequency phi maximum. And what I have here is my what? Average value of flux. That's the average value of flux, or you call it the average rate of change of flux. Now you recall that your form factor is equal to the RMS, which is what we have to obtain, divided by what? The average value of loss. And this is equal to what? 1.11. Now, if I make my RMS straight to the formula, I will have RMS to be equal to what? The form factor multiplied by what? The average value. The total form factor is 1.11. And the average value is what? What I have here. That's 4 multiplied by the frequency multiplied by the what? Average rate of loss. That is phi maximum. So that average value is 4 times frequency times phi maximum. So I'm going to have 1.11 multiplied by 4 this times this. Now I will have what? 4.44 F maximum. Now you have to recall that your root mean square value is that of a what? A transformer. Because I have to find the RMS value of a transformer. And a transformer has the primary and the secondary windings. Primary and secondary windings. And these windings, you have the number of turns. So your RMS value will be equal to 4.44 multiplied by frequency multiplied by the maximum flux times the number of turns. The number of turns here, N, can be either that of the primary or that of the secondary. It can be either, N can be either that of the primary or that of the secondary. Either way. So here we are going to use N. We are not going to specify if it is for primary or secondary. Or let's assume they are equal to each other. So we have the root mean square value now to be 4.44 N F multiplied by what? The maximum flux. Again, you have to recall that your maximum flux is equal to area multiplied by the what? Maximum flux density. So this is flux density, is the area. So I'm going to, let's call this one equation 1 and equation what? 2. I'm going to substitute this here in equation 1. So substitute equation 2 in 1. My RMS value is equal to what? 4.44 multiplied by N multiplied by the frequency multiplied by the what? Area multiplied by what? The B maximum. Don't forget that I've substituted area times the maximum flux density for flux. So I can now conclude that from the question given that E equals to 4.44 because the root mean square value here is what? The EMF. So E here is 4.44 and A F B maximum. All in what? In volts. So we have been able to show that the root mean square value of EMF induced in the winding of a transformer is this. Again, don't forget, all you need to do is remember to draw your wave diagram of flux so you can determine the average rate of change of flux. Then when you get that, you have to recall that your form factor is equals to 1.11 and it is root mean square value of average value. Then you substitute this form factor and average value by making your RMS formula and your RMS ERMS. Let's put this here. That is EMF. That is 4.44 N, where N is number of turns multiplied by area multiplied by the frequency multiplied by maximum flux density, all in volts. Thank you very much. Please do so well to like, comment, subscribe and share.